This is 2.2 functions. We've talked about functions before in this class earlier on in the year, and then also you talked about functions in Algebra 1, also Algebra 2. So let's cover a couple definitions. So a relation is basically a comparison of two quantities related by a rule. We see this all the time, typically used by formulas. So even if I had, y equals 2x, something like that. So the rule is x and y are being compared to each other by a rule. So the rule is multiply everything by x by 2, and then that's what y is. So there's the relationship between it. So it could be y equals x plus 2. I mean, whatever it is, there's a rule going on, and that's a relation. Now, a function is a relation that is one-to-one. That you definitely need to know. It's an x value, has only one y value. A lot of times when matter of fact, let's look at this example right here, y equals x plus 2. If we made an xy chart, and we started plugging in random x's, like 0, 1, 2, 3. So if we put one x in, then notice we get, for 0, we get one number out. We put one number in, we get one number out. We put one number in, we get one number out. We get one number in, then we get one number out. That's what a function is. It has to be one-to-one. If, for instance, I put 3 in again, I got a different value, then it's not a function. So if I put one value in, I should get only one value. It's not like a jackpot, like you get 2 numbers out or 3 numbers out. It cannot happen. Not to be a function. It could be a relation. That could be a relation, but it can't be a function. So the domain is the set of inputs. A lot of times what you learned earlier, like the domain is your set of x, is your inputs, and then your range is your set of y, or your outputs. All right, so let's look at some examples. So here's a bunch of functions, or they may not be functions. These are all relations, okay? Because you're just comparing from x value to y value. So these are all relations, but let's see if they are functions. Remember, the definition here is it's a relation that is one-to-one. So if I put 0 in, I get -3. I only get one number. If I put 1 in, I only get one number. If I put one number, I get one number. If I put 1, I get 1. If I put 1, I get 1. Yes, that is a function. So that is a function. So notice the green. So notice here, when I put -4 in, I got 2. But here it says when I put -4 in, I got 0. So that is not a function. Let's go to the red. Notice when I put 1 in, I get 1 out. So yes, that is a function for every single input. The same thing when you go to this color down here, every number that you put in, you get one number out. So that is a function. When you go to the purple, notice you have, when you put 4 in, it says you get 3, but here it says when you put 4 in, you get 5. That is not a function. And then notice the blue, every number that I put in, I got a number out. So that is a function as well. All right, so are these functions? Well, there's a couple things what you can do. I suggest you solve for y first. You don't have to, but I strongly suggest that you do. So that's going to be -x² plus 1. And then if you looked at the calculator, there's if you actually plug this into the calculator, you don't have to. You can always just graph it manually. You don't have to use a calculator for this. But -x² and then plus 1. If you graph this, notice the XY table as well. For every number in, I get one number out. That's what you got to test. You got to see if every number in, I get one number out. So when I put -1, did I only get one number out? And that's what you have to check on this when you're doing to see if it is a function. Also, there's another thing that you can always test. You should remember this from previous discussions that we've had, and even in Algebra 2, there's a thing called a vertical line test. So if you draw a vertical line, like that parabola that we just had, notice it was a parabola going down. If you draw a vertical line anywhere on that graph, notice it only crosses at one spot. It only crosses at one spot. It only crosses at one spot. So that's the vertical line test. You can easily see that this right here is a function. It only crosses at one spot. If you happen to have a function that, you know, whatever it may look like this, and then this, and then this, I mean, whatever it looks like. If you draw a vertical line, notice it crosses at more than one spot. So this is not a function. So that's something you can always tell if you look at the graph value. Again, does every x have a y, just one y value? So again, if you solve for y here, you're going to get y equals plus or minus the square root of 1 plus x. Now you can see automatically without the graph, you can see what this is going to look like. Because of the plus or minus here, you can see that we're going to have two different values here. If you graph this, you'll see on the calculator, if you graph this, it's going to look like this. That's what it's going to look like. And if you draw your vertical line, notice it crosses at two spots here. So it has, for x, you know, whatever x is, it has two y values. That's impossible, okay? So this is not a function, where this one is a function. All right, so function notation, a lot of times you guys see y equals x squared plus x squared minus 3 as an example. Well, that's the same thing as f of x equals x squared minus 3. And so a lot of times we have an xy chart, and so if I wanted to literally, you know, this is x right here, and this is my x column, so f of 0. So when I put 0 into the function f, and again, f is just the name of the function. We just like we have names, we call this function a certain name. We're just going to call it a certain letter f. So when I put 0 in for x, I notice I get negative 3 as the output. Input, output. So f of 1 is negative 2. F of 2 is 1. I'm just reading from the xy chart. F of 3 is 6. So again, that's how you do function notation. Now, evaluating a function. So g of 1. So let's say this is your g function right here. And again, I'm just naming it the letter g. So if I wanted to evaluate g of 1, you can literally just plug 1 in right here. Then evaluate that. Let's see, that's negative 1 plus 5, that's 4. So g of 1 is 4. And again, if you want to make an xy chart, when I put 1 in, I get 4 out. That's a graph. So when I put 2 in, the same thing. When I put 2 in, you can evaluate this, and you get 5. So when I put 2 in, I get 5. So we can, and by the way, you can do this on the calculator too. So if you plug this into the, your calculator, and then just simply looked at your XY chart, you can get all the values you want. Now, sometimes I don't want to put in a number, I want to put in a variable, because remember, variables just represent numbers. So all I'm going to do is replace the x, just like I replace the x with a 1, just like I replace the x with a 2, I'm going to replace it with a w. So negative w squared plus 4w plus 1. And that's all I can do. I could just simply exchange the x for a w. Well, notice here, I'm going to exchange the x for an e minus 2. So I'm going to literally exchange it for an e minus 2. And so here we would have to evaluate this, so you'd have to write this out twice in FOIL. Distributive property here. Let's see, this is going to give you e squared, and then negative, so negative e squared. So for e, which is positive 4e. I'm foiling and distributing the negative at the same time. And then you're going to get negative 4. We're going to simplify that. So negative e squared plus 8e and negative 11. So a piecewise function we've touched on before as well. So this is just a reminder. So this is a function. If I wanted to evaluate f of 1, Well, 1 is, notice it's greater or equal to 0, then I use this function. So then I plug 1 into there, so 1 minus 1, that would give you 0. If I put negative 1 in, well, negative 1 is I'm going to use this one right here because it's less than 0. So I'm going to put negative 1 in right there. I put 0 in, so notice this is greater or equal to 0, so 0 minus 1, I'm using the second function, I'm going to get negative 1. F of 3, I'm going to use the second function because 3 is greater than 0, so 3 minus 1. And then f of negative 2, so put negative 2 in, I'm going to use the top function. And again, if I wanted to graph this, I could. Notice this is x squared plus 1. It's a parabola, but it's only defined on values less than 0. And then for x minus 1, you can graph that, but it's only defined when it's greater or equal to 0. So again, what you could do is just graph the entire function. Let me do that. So x squared plus 1, if I graph that, it would look something. Well, I guess we can make an XY chart. Well, we sort of did it already. We have, these are my XY chart values right here. So when I put 1 in, I get 0. When I put negative 1 in, I got 2. When I put 0 in, I got negative 1. We'll get to that. And when we put 3 in, we got 2. Negative 2, we got 5. So notice we have a parabola. Let me graph this one in green. So we have a parabola, the left half of the parabola. And notice this is an open circle on the parabola. Notice it's an open circle on the parabola. And then the line starts here. It's actually not a line, it's a ray. Because it's only starting at x values that are greater or equal to 0. So the piecewise function, if we graph that, it would look like that. All right, so let's look at this. 2 examples. Find when f of x equals 0. So notice this, the directions, it doesn't say x equals 0, it says f of x equals 0. So in other words, I'm going to replace the whole f of x equals 0. And then, of course, I could factor that to x minus 3, x minus 2, which means x equals 3 and 2. So when x, so in other words, when x is 3, when x is 2, f of x is 0. Remember, this is the same thing as f of x. And then this one right here, find when f of x equals g of x. So in other words, you're going to take these two functions and set them equal to one another. And then solve this. So here we're going to get 2x squared, let's see, minus 3x plus 1 equals 0. Back to this. So here then we get x is 1/2, we get x is 1. All right, this is the first part of 2.2, the first video. So you'll need to watch the second part of the video to get the rest of the lesson. Oh, by the way, just real quick, back on this piecewise function, just a quick comment. There is a way to graph piecewise functions, and I forgot to mention this. So if you want to know how to graph piecewise functions, on your graphing calculator, you just need to ask me, and I'll be glad to show you.